All right, third topic. Remember, there's 4 different topics that we deal with in the statistics world, and this one is probability. So probability, in the AP test, if you're taking the AP test, you can expect 15 to 20% of your problems to be probability problems. Now, probability stretches a lot of different forms. So let's talk a few of those different forms that it comes in. One of the ones that's super duper popular is normal probabilities, right? And so normal probabilities, literally, you just need to know how to draw the curve, label it, right? If you had certain labels that you need to put under those, then you would shade the section that you need. And the most important part about normal curves is area equals probability. Area equals probability, right? So there's always going to be things like finding the z-score, which is your value minus the claimed mean and the basic standard deviation to find normal probabilities on that, right? So we did have that that we could always do. And then that started turning into sampling distributions, which turned into inference later down the road. But let's just stick with probability for the moment. So probability, okay? That's one of the probability ideas. Another one was things called the addition rule. And the addition rule, remember, was a basic probability that says the probability of A or B, which is equal to the probability of A plus the probability of B minus the overlap, probability of A and B. Sometimes you'll see this on a formula sheet as or being meaning the union of A and B. So probability A plus probability of B minus the probability of A, and this is the and sign now, it's that upside down U. It's not truly an N, it's just an upside down U. So you could write it either way that you want, addition rule. So with the addition rule also came the idea of Venn diagrams. Venn diagrams where each of your different pieces, your events, were here. Remember, if there's overlap, that's what you're trying to subtract off there, right? So if there's overlap, like this, right here, we would say that these are not mutually exclusive, right? Remember doing that? Not mutually exclusive. If there was no overlap, quick representation of that, then we would say that these are mutually exclusive events, right? Definitely some vocab terms there. Addition rule. When do we use the word addition rule? When I hear the word or. We like to use the addition rule. Okay, that was one. Let's come on back. Let's talk about multiplication rule. Multiplication rule. Multiplication rule is when we have multiple events. Oh, sorry, not events. Let's do that again. Multiple trials. Right? Multiple trials means multiply, so that we'd say the probability of A and B, also known, this and is A and then B, is equal to the probability of A times the probability of B, given A has already occurred. Yes, that is a conditional distribution right there. So if probability of B given A is equal to the probability of B alone, then they are independent. This is a good little thing just to keep in mind, right? Because sometimes they'll just say, hey, are the events A and B independent? If they're just looking for two events being independent, literally chalk up the formula here and try it. Okay, so that's what it would be right there. If A and B, if B given A is equal to B alone, then A and B had to have been independent because A had no merit on it. If there is dependency there, you're gonna have to think through the dependency. Just gonna have to do that. Okay, so that's what we got there on the multiplication rule. We have the conditional probability. And conditional probability is basically taking that probability of A given B. So if I just really needed to work this out, it's the probability of A and B, so also known as the intersection, over the probability of B. All right, so whatever this is here, that's what goes on the bottom there. Okay, but here's some other form that you might see it in. It's a probability of A intersection B, right? That's what how they like to say it sometimes, over the probability of B. These are saying the same thing. I'm just giving you a different notation on that conditional probability, right? So that's what that looks like there for some probabilities. Another thing, so like we had the Venn diagram as one visual. Remember that we had a thing called the tree diagram. If you wanted a second visual on these things. Now, tree diagram is used for like the multiplication rule and things like that for multiple levels, multiple trials. So, and we like to look at things like, you know, like half the people use steroids and don't use steroids, and or not half the people, let's say 10% of athletes use steroids, 90% don't use steroids, and then they take tests. You get positive negatives, you get positive negatives, right? And if you do take steroids, 95% of the time it'll give you a positive test, but 5% of the time it gives you a false negative. And if you don't take steroids, let's say 8% of the time it gives you a positive reading when it shouldn't, and 92% of the time it's actually showing you the correct reading of a negative, right? So this would just be a tree diagram. This just kind of helps us show what's going on. So it's a great visual. You don't have to do tree diagrams. You don't have to do Venn diagrams, but these are just great visuals to show different probabilities that you have, right? And then you can work in two-way tables, and they'll do a great job on probabilities as well. So this is basically your probability idea here. So these were the basic probabilities. And then we did move into some other probability realms. So let me just kind of highlight those real quickly. We looked at discrete probabilities. That's when you're going to get it in a table form, and then you're literally just pulling numbers off of a table. So discrete probability, most people get a pretty good handle of that because they give you the table of values, and it's easy just to kind of look at the table and pull the right numbers from them. So discrete probability was fine. Then we had binomial probability, right? Binomial probability. That's when we can identify if there's bends. So is it binary, success and failure? Are all the trials independent? Did they fix the number of trials? And is the success the same every single time? If so, we use the calculator function, right? Binom PDF and binom CDF to help us out with that, right? And so those would be my binomial distribution. And then we had a geometric probabilities. Geometric probabilities. How are we going to identify if it's geometric? Bits. Binary, success or failure, independent trials. Success is the same on every trial, but the number of trials until success is what we're looking for, right? So the number of trials until the first success. So I'm looking for first success. Here we have a set number of trials. That's what makes these different. And this has a GeoMet PDF and a GeoMet CDF for those. Just remember, if you're using the PDF function, we're looking for an exact value. So what is the probability that exactly 7 out of 10 occur? That's a binomial PDF. What's the probability that first success on exactly the 7th trial. That's a Geomet PDF. We will use CDF for up to and including the success, right? So binomial CDF, we would say, if they said, what's the probability that at most it takes 7 shots out of 10, right? Or at most you get 7 out of 10 shots. Geometric, it would say, at most it takes 7 shots to find your first success. Okay, that's a CDF, up to and including those right there. All right, so those are some terms. I guess I can come back over the normal probability if you want to sketch this down. We used in this extensively normal CDF in our calculator. Lower bound, upper bound. That's this right here. That is the lower bound. Yep. Upper bound. Yep. And then you always want to put in your mean and your standard deviation. Okay, so that's some calculator functions, just in case you are using it. I would use it for sure. So the calculator function, calculator function, calculator function, calculator function. Okay, a lot of calculator functions there. All right, and what else did I miss? I just missed one other thing. That is going to be our complement rule. Man, why did I let me so long? Complement rule. Complement rule. That is, if I wanted to know the complement of A happening, it's going to be 1 minus the probability that A happens. This is a popular way to do, like when they get too extensive of a problem. It's a great way to do that. Okay, there we go. That's really that's a good set of probabilities. I mean, it's hard to really kind of throw more out without looking at problems. So now you got the basics. Time to do some problems with that. All right, so check out My Open Math. Check out some of the free response questions.